Hello, everyone. Welcome to today's webinar, Deploying the ForgeRock Identity Platform using DevOps Techniques. We're thrilled you decided to sign in today for this unique opportunity to learn more from a content expert. And for a more in-depth learning experience, I'm excited to announce that we have just marked our June 11th Deploying the ForgeRock Identity Platform using DevOps Techniques class, guaranteed to run. Today's webinar is hosted on Zoom, and the features you will experience today are merely a snippet of how we deliver our live online classes, which we call IMVP. If you enjoy the presentation today and are interested in learning more about training anywhere with IMVP, please visit our website or contact us. During today's webinar, everyone's microphones will be muted. So if you have any questions, please don't hesitate to post them in the Q&A box at the bottom of your screen. You'll notice there is also a chat window. Whichever tool suits you best, you are welcome to use. This webinar will be recorded, and we will send a copy to each and every one of you by the end of the week. Today's webinar is presented by Matthias Trissel, Senior Technical Instructor at ForgeRock. Colleagues of Matthias endorse his extensive knowledge, professional service, and strategic planning, just to name a few attributes, and I couldn't agree more. So without further ado, I'd like to introduce to you Matthias Trissel.
Yeah, hello and welcome. As Michelle mentioned, my name is Matthias. I'm the ForgeRock instructor. Well, we have a couple of instructors, but I'm the one who is employed directly by ForgeRock. I have a few more roles in ForgeRock, like training development as well, for instance, but I'm also leading a lot of the classes. And it would be my honor to see you again at the live class in a couple of weeks, which Michelle also just announced. What I'm going to present here is about maybe 5 or 10% of the slides and the content we will have in the real class. So it is an introduction to the real class we have about the ForgeRock DevOps techniques and a few pieces of information around that. So what you see is that is the real material, but only a little bit of it. Yeah, with that, I'd like to start. I have to show you some legal slides if my presentation cooperates here. This one, I guess that's important for the recording. So we'd like to give you an introduction to ForgeRock DevOps. And well, we'd like to get you started on our plan or our idea how you can use DevOps techniques to deploy the ForgeRock software. So we're going to have some DevOps example. I'd like to give you a short introduction into the cloud deployment model. The cloud deployment model is a pure ForgeRock thing. So it's one of these 3-letter abbreviations which are around in the Kubernetes and cloud and Docker environment. But this is actually not an official term. This is a ForgeRock official term. It's kind of the reference implementation for deploying ForgeRock software in the cloud with Kubernetes and Docker. I may also like to introduce you to some Git repositories where you can download the Helm charts, for instance, for the cloud deployment model and some example configurations for the products which you can use to play around with the products. It's more or less starting one script. If your cluster in your cloud environment is set up properly, then you just run one command and it installs a lot of stuff and you can try and start playing around with the ForgeRock software. Just a reminder, what is the ForgeRock Identity Platform? There are different areas. There's access management, identity management, directory services, identity gateway, and edge security. Now, the first 4, access management, identity management, directory services, and identity gateway, those are deployed with the cloud deployment model. The edge security is an extra part which is about Internet of the Things and so on. That's not that cloud relevant in the moment, so this is not covered by the cloud deployment model at the moment. I just have to make sure that I use those slides in the right way because you may have recognized there are vertical slides and horizontal slides. So I just have to avoid missing one of the vertical slides. Now, when we at ForgeRock talk about DevOps, what we mean is Kubernetes. DevOps is a huge area, right? It starts with continuous integration services and building the software and everything. But what we mean in our documentation, for instance, when we refer to DevOps, it is always DevOps with Kubernetes. Whether you want to use that on Google Cloud Platform, Amazon Web Services, Microsoft Azure, or you want to play around on your Minikube, on local, on your desktop, for instance, it's always Kubernetes. And well, we hope Kubernetes is Kubernetes. That's the idea, at least, right? But as I said, the connection between DevOps and ForgeRock is Kubernetes. We also have to mention Docker, of course. Well, Kubernetes, I guess, is restricted to Docker containers. So we're talking about containerization, and what we mean is Docker containers. What you also need, of course, is load balancer and a DNS set up correctly and public key infrastructure. I don't have the time to really talk about that at all here, but of course, that is also covered by our cloud deployment offer. So what this ForgeRock provider said, there is a kind of reference implementation called the cloud deployment model. And if you go to our webpage, you will even find a video which actually shows live the deployment of the whole cloud deployment model. If I may just go to, let me quickly go to ForgeRock.com. Actually, my screen is very far away. I don't really see what I'm looking at. So lucky me, I got the right link. And the products you will see down here, DevOps. And there's a little bit of information about DevOps. And then there is that demo video here. I'm not going to click that, but I can only invite you to click it. It is starting with some marketing information, and then we're going to start that script. And you see the whole demo video is only a little bit less than 4 minutes. What you will have after that, or what the people who started the script here will have, is a deployment of the access manager, the identity manager, the directory server, and the identity gateway from ForgeRock, loaded with 100 million user entries, ready to start playing with it. And you can do the same. If you build a cluster of appropriate size in Amazon or in Google, then you can also run that script, and it will do the same for you, and then you can start playing with it. And of course, you can also adjust it, adjust the configuration to your own needs. If you don't want to play with 100 million entries, you can also start a little bit slower. There's another parameter you hand over to the script, and then it will only create everything for 1 million or for 10 million entries. With that, back to the presentation. What it actually builds, what that script builds, is a Kubernetes cluster, here in this case built on Google, with 2 high availability zones, with 2 nodes in each zone. I hope you can see my mouse pointer when I try to point around a little bit here. It installs, of course, the ForgeRock software. There is the identity gateway, there's the identity manager, there's the access manager, and there are 3 directory servers. If you're familiar, and I hope you are familiar with the ForgeRock access manager, you will know that it likes to have a couple of directory servers available. One is the so-called CTS, the core token store, or core token service precisely. One for the configuration directory, and one for the user directory, of course. And of course, we mirror that all into a second zone, so to have it redundant or high available. What you also get is a Postgres database. This is actually what we're using at the as a repository for the identity manager. There is a cert manager involved. There's an ingress controller involved, of course. There is Grafana for monitoring, Prometheus actually, which is collecting the monitoring information, both from your cluster and your Kubernetes engine and from the ForgeRock software. So you get all of that installed and can start playing with it. And I said, the video, if you want to watch the video, that would actually introduce you to it. Now, the class we're talking about here, or a little bit focusing here, is called FR523. And well, these are the goals for the class. We try to successfully deploy and manage the ForgeRock Identity Platform software in a Kubernetes cloud environment running on Google Kubernetes. So we are doing it in the Google cloud, but as I said, if you have somebody who creates the cluster for you, or if you know how to create the cluster correctly in the Amazon environment, then you can actually do it in the Amazon environment as well. It's a workshop. If you have been to some ForgeRock training, you may have seen that we usually provide material which is very, with very detailed lab descriptions. This one is a little bit different. The reason why we run it differently here is that the whole Kubernetes container and Docker deployment is still so active and so quickly, so fast changing, that we could probably never keep up with the usual code material, sorry, the usual training material because the life cycles are too slow for that. So we decided we do it in a way which allows us to update the material much faster. And this is actually that workshop character. We don't leave users or students more or less, well, we never leave the students alone, of course, when they do the labs, but usually students would do the labs more on their own and more on their own pace. In this class, we try to run the labs all together, which encourages a lot of discussion. So we have more interactivity, more discussion than in the other classes here, even if we try to have a lot of interactivity in the other classes as well. So there's no very detailed lab guide, but honestly, at the end of the day, whatever you have to do, you will find in the guide which we provide you with, and then you will also get through it. Here's the agenda. We have 3 days, 4 chapters. Honestly, we produced a little bit too much material, and you see the last part here is optional. It depends on how the class runs. It also may depend on what people are more interested in. So we have chapter number 1, where we give you just a introduction into how we handle the cloud deployment here. Then in chapter number 2, we're going into more details where we also allow you to adjust things. So in the chapter number 1, we are actually deploying something which is called the CMP platform. You basically just run a script and that deploys everything for you, but in a much smaller scale as what in the video you have maybe seen or you may want to watch. But we don't change anything. We just actually see if your cluster is prepared correctly, then everything works nicely. In chapter number 2, we're going into much more details and try to show how we handle things. In chapter number 3, we're then going into the cloud deployment model. So this is actually where we really start to explain what happens during that magic script that deploys your cloud environment with 100 million users, and how you prepare the cluster for that adequately, and these kind of discussions we will have in chapter number 3. Chapter number 4, if there is a chance to go to it, if we have the time, we would actually look into a rather common use case probably. We expect that a lot of customers already have everything installed on premises or in the cloud, but on dedicated machines. And now you want to move it in a Docker container-driven installation, and what you have to look at and how you can migrate your whole configuration into a Docker-based configuration. This is actually what we are going to look at in chapter number 4. In our training, we usually try to start everything with use cases. So this is actually the use case for the FR523. We try to understand how ForgeRock software can be deployed using DevOps technology, of course, determine which requirements are necessary before you start deploying the ForgeRock software, learn the overall process for deploying ForgeRock software using DevOps techniques. And I said DevOps techniques in this case means Kubernetes. And finally, quickly deploy the ForgeRock Identity Platform software for an evaluation purpose or for trying it out. We do have quite some requirements here. I don't think we send anybody home who shows up in a training or doesn't have the requirements, but we really recommend that you have these prerequisites or you have the pre-knowledge. Otherwise, the learning curve might be just a little bit too steep. So you should not actually, well, we have the start here guide, which I have a short look in a few minutes maybe. You should not actually ignore those. We do expect you, when you come to the class, that you also have a bit of knowledge about how Docker works, how Kubernetes works. Otherwise, as I said, it's just too much information we try to share in those 3 days. The slide actually also focuses here on what you should have as pre-knowledge when you want to do it at home in your own project. So do not attempt to deploy ForgeRock Identity Platform to production until you fully understand the DevOps technology. And again, DevOps technology here means Docker containers used in a Kubernetes environment. And you also have to have full knowledge about your provider, Google or Amazon or Azure. Those are the ones which are officially supported by ForgeRock at the moment. Azure with a little bit of restrictions, but we would have to go in much more details to see what is the restriction. And actually Azure is picking up rather quickly as well. So I believe we will very soon fully support it. You should have experience with the DevOps technology in critical situations to be, well, it's critical to succeed. So you should actually have that pre-knowledge. I'm right at the moment actually sitting with ForgeRock support people who are already working on support cases where our customers have it deployed, even often with their own Helm charts into the cloud. And I see what we sometimes get as questions, and well, here's the recommendation again, or the requirement again. You really need to have your cloud technology, your Kubernetes technology under control. Otherwise, it does not make sense to start deploying the ForgeRock software. And this doesn't have to do anything with ForgeRock at all, of course. It's just when you have to start troubleshooting, you have to know the environment in which you're troubleshooting. You wouldn't like a Linux administrator to administer Microsoft environment, right? So it's the same thing here. Now, talking about documentation, we have quite a few documents about our platform installation with Kubernetes. So here's a very quick run. You may want to start with which number 1 points here at Start Here guide, which basically is one page and tells you a bit more about the other documentation. Then there's the Quick Start guide. The Quick Start guide actually describes what you can do to quickly install everything. And this is actually as what we also start with in the class. You basically run one master Helm chart, which then actually calls a few other Helm charts, which deploys the directory server and the access manager and the identity manager all together. Of course, the release notes are very important, always, especially when you migrate from one version to another version. And then there is the developer's guide. Now, mentioned with number 4 here. First, the term developers here doesn't mean people who write code. The developers here are those people who deploy everything to the cloud. So who do the deployment in your own or in the chosen cloud environment. And these are just called developers, and therefore we call that the developer's guide. So the developer's guide actually has rather detailed instructions and background information about what is going on. But then there's also a cookbook. That would be number 5. The cookbook actually called the Cloud Deployment Model Cookbook. And here you see again the deployment model. Again, the Cloud Deployment Model from ForgeRock. The cookbook actually, just like a cookbook, it goes through the different steps. It doesn't really explain the steps and what is going on. It just tells you what you have to do before you're even ready to deploy that deployment model from ForgeRock with 10 or 100 million entries. Finally, once you're in production, you might be interested in the site reliability guide. Now, you will have seen already that the cookbook and the site reliability guide actually appear several times here, depending on which cloud provider you're using, whether you use it in Google or in Amazon. Very quick here, the steps you do when you want to start with it. Well, first, of course, you have to make a decision whether you want to deploy locally, which would mean Minikube at the end of the day, or in the cloud, and then you have to have a cloud provider and an account on the cloud provider, and you have to pay the cloud provider, of course, for the resources you are using. Then you're going to deploy everything and finally verify it. I mean, of course, I have to go in a little bit more details on what that means. But before we go into that, I would like to show you what is the requirement you should have before you can even start playing with our cloud deployment model. On the left-hand side, you see what you have as a prerequisite on your, let's say, desktop or whatever the machine is from which you want to operate everything. There is a Docker engine and a Docker client, which you need. This actually you only need when you want to, and you have to actually, to get a supported situation, when you want to create your own Docker images. What we do provide you with are the Docker files, which you can use to create your own Docker images from which you then create, or from which Kubernetes then creates those Docker containers. The Docker image, which you can download from our Docker registry, which is public and open, are not supported. which sounds strange maybe, but if you know Docker, then you may say yes, of course, because such a Docker image does not only contain, let's say, the access manager. You probably know when you run the access manager, you need a Tomcat or an application server. We usually choose Tomcat here, but we don't support that Tomcat, right? We only support the access manager running on the Tomcat. That doesn't mean that our support immediately refuses to answer when you have a question about Tomcat. Sometimes we even overwrite things which are done wrong, not in Tomcat, but there was another application server where our support people had to, let's say, find a workaround of something in the container. But usually this is not what you can expect from our side to be supported. Then the Tomcat needs Java, and Java needs to have runtime environment. So we don't support any of those. It really depends on your own security requirements. For instance, how often you need to or want to update the Java version, for instance, on which you run your Tomcat. That really depends on your requirements, as said, and this is why we cannot. If you are running in a very high security environment, you probably have to do that more often than other people. But we can't always keep the pace with our own Docker images which we provide you with. So that's the reason why the images itself are not supported, but the Docker files to create those images, they are supported. Then you need and only when you create those Docker images, you need a Docker client and a Docker engine here. Then there is, of course, a Kubernetes client. You want to run some kube control and kube context and so on commands locally, which then usually talk to your cluster and do some stuff on the cluster. And down here, we also mention Kubernetes utilities like Kubernetes namespace and a few other utilities. Our deployment heavily relies on Helm. So you also need to have Helm charts. We do provide you with the Helm charts, but of course, on your client side, you need to have installed Helm. Now let's move already over to the server side, because Helm talks to a counterpart on the server side, which is called Tiller. And you have to have exactly the same version, or more or less exactly the same version of Tiller corresponding to the Helm client you are using. So it's your responsibility to also have that set up, a Helm on your desktop where you operate everything, and a Tiller on the Kubernetes side. Now you also need to control and update and configure the cluster here. If you do that in the Google Cloud environment, then you would also use the Google Cloud SDK or the G Cloud command, which you have to deploy locally as well. As I said, we are offering Helm charts, which you can download from a Git repository, which you will find at the GitHub/ForgeRock/ForgeOps. This is where you will find those Helm charts. Those Helm charts you would usually download locally on that desk computer from where you operate things. And as I said, they are supported. You get more than just the Helm charts. There is a bin directory with a couple of scripts as well. As far as I know, the scripts are not 100% supported. What do the scripts do? The scripts, for instance, help you to create a cluster. So there is a create cluster script for creating a cluster in Google. There's a create cluster script for creating a cluster in Amazon. You may want to adjust those scripts a little bit to your needs. Those scripts actually often don't, well, they care more about performance than your budget, let's put it that way. So they may create SSD volumes where you may say, I don't need a super fast volume for just playing around here a little bit. I want to do that with a standard volume in the Google Cloud, for instance. And then you would actually adjust this script to your needs. Or you don't use a script, you use the cookbook, because the cookbook also describes what you have to do to create that cluster that fits our needs. On the cluster, we need a little bit more than just a Docker engine. We need an ingress controller. And again, it's your choice. Do you want to spend a lot of money and use Google's worldwide available ingress controller? Or would you say, I just want to play around a little bit, so I want to use a little cheaper version. And this is what we use in the cloud, for instance. So we deploy an Nginx, which is configured as an ingress controller. We still want to connect to our machines with HTTPS because you use it for authentication. So HTTP is not really an option. So you need certificates on that ingress controller, and somebody has to maintain those certificates. And therefore we are using a certificate manager, which is deployed as a other help chart or as a pod. And that allows us actually 3 ways to use those certificates. You can either use a very cheap version again by just operating with self-signed certificates, which of course then usually means they are not routed in the public DNS or not accepted on your browsers. So you would actually use your own domain like example.com, which means of course you have to update your client-side DNS. Most of the people just actually editing the local host file. You can also use Let's Encrypt, for instance, if you want to have some more publicly accepted certificates, or of course you can also get your certificate from your preferred certificate authority and make the certificate manager then use that on your ingress controller. Then in the class here, we are actually using different namespaces. We don't want to have an extra cluster for each student, so each student actually gets their own namespace, and then the students deploy everything in the namespace. There's one last thing which I didn't mention, and that is another Git repository down here, which is called ForgeOps-init. You find it at the same place under GitHub/ForgeRock, and that contains sample configurations. We need those sample configurations to have something to play with, right? This is actually where you can find it. What we usually do, or what people usually do, is they start with that, and then they were starting to get their own configuration, and then they merge it to configuration, or they just build their own Git repository. The configuration in our model needs to be available through the internet because our Helm charts actually tell some Git init pods on the, actually precisely it's Git init containers on your Kubernetes installation to download the configuration from the Git repository of your choice. So you need to make it available. If you're using your own repository, then of course you have to make sure that the machinery here has access to these files. Now, a little bit more detail, what we're doing. So again, remember the upper part here, that is actually the same as before. Do you want to do it in the cloud? Do you want to do it on Minikube? I just focus here on when you do it in the cloud. So is a third-party software installed already on your computer? We're talking about the third-party software here. If that's done already, you can jump to the next part. If it's not, then please install it. Is a cluster already on the cloud platform deployed? Well, here we actually play it easy. We say, yes, it's okay. If you don't have a cluster, well, ask your administrator. That's, of course, the easiest way to get a cluster. Then it continues a little bit. You have to set up a Kubernetes context to make sure that your Kubernetes client programs like kubecontrol, for instance, talk to the right context, to the right cluster, to the right namespace, and so on. And you have to set up Helm, of course, that was mentioned before. And then the next question, is there an ingress controller already ready to be used? And if not, then of course you need to create one. You may again ask your administrator to do that. You also need a certificate manager. For some reason, we just take that for granted, or well, it looks like here that you have to install it, but of course it's the same thing. If you already have one, you don't need to install one, and you only need one per cluster. And then you need a Kubernetes namespace, and this is actually your requirement to start deploying your cluster or running your Helm charts. A few more screenshots here on where you get information or where you get the Helm charts. In this case, for instance, there is, as mentioned before, on the GitHub, on the ForgeRock, you have ForgeOps. This is a Git repository where you find Helm charts. You just can see it down here. This is actually where the Helm charts would live. And we have Helm charts to deploy the identity manager and the access manager and the directory server. And we have kind of a master Helm chart, which actually would deploy everything together. There's also bin directory, as mentioned before. In that bin directory, you will find a few scripts, quite a few scripts actually, which help you to create clusters, which also help you to get rid of everything. So there is the famous remove all script, which actually would strip your namespace clear again. It removes all the deployment you have in that particular namespace. Yeah, well, the CMP platform, that is that master Helm chart, which would then deploy an access manager, two directory servers in this case, an identity manager, a Postgres database as well, and a IG. But the configuration is very sparse. There's no user in that. There is no configuration in IDM. So it's a really very sparse deployment here. But here's a little warning. That's why I put in that slide. The CMP platform exists in our version 6.5, but not in 7. So if you download here the Helm charts and you use the master branch, you can see the master branch here, then you will not find that Helm chart CMP platform, because it just turned out it's a little bit too complicated. It's nice, it said it does everything. If it works, it's nice, but if it doesn't work, then it's difficult to debug. And I guess that's the reason why we decided not to provide it anymore in the next version of our software. Yeah, that's just actually a summary of what you do next. You install the CMP platform, for instance. If you choose to install the CMP platform, it takes a while until it deploys. You may even see some error messages. I just did it actually with 5 or 6 people here in the classroom, and 4, I believe, even got horrible error messages in the beginning, which means after about a minute. And I asked them to be patient. And guess what? After 5 or 10 minutes, everybody had everything installed fine. So if you get error message in the beginning, be patient. Kubernetes is supposed to do the magic, right? And then everything will be deployed. Here in the classroom, as I said, we're going to configure the host file because we don't want to use an extra domain which is routed in the internet. We do everything in example.com, which, as everybody probably knows, is not routed in the internet. So we need somebody else to resolve the domain names, and that is your local host file. You don't have to fiddle around with your local host file. We will also provide you access to our good old CloudShare environment, where you have a virtual machine if you come to the class, so you don't have to be afraid that you have to change your own host file of your maybe locked down computer, which you got provided by your company. We can avoid it by using the virtual machine, which runs in CloudShare. And if you have been to one of our classes, you know CloudShare. Good. If that is done, then you should be ready to access your access manager and create users or create authentication chains or authentication trees or whatever you want to do. Start playing with it. So this is actually what it looks like after you run that CMP platform Helm chart, for instance, very similar to what you would also get through the cloud deployment model. So the big difference to the slide I showed before is down here. So let's focus into that a little bit. You will get 3 directory servers, one serving as the CTS, the core token service, one as the configuration store, and one as the user store. Talking about money again, maybe, we decided by default that the core token service and the user store need very fast volumes. So they by default actually have their database files on an SSD volume in the Google Cloud, where the configuration store, which doesn't need that super performance, is actually done on standard volumes. You get OpenIM, you get OpenIDM, you get OpenIG, and you get OpenIDM Postgres. What that is, it's actually a standard Postgres container, which we download from a registry, and we just use it as the repository for the identity manager. So this is not somehow a special version of a IDM Postgres. It's a standard Postgres. Well, it is a little bit special because after it's deployed, we of course have to create a database or a table space or whatever you want to call it in here to have the tables available which are needed by IDM. You may also have recognized that the people obviously who are playing around with our DevOps environment are pretty traditional. So they still call our access manager OpenIM and our identity manager OpenIDM, or our IG OpenIG. That doesn't mean those are the old versions, right? This is currently, if you choose for 6.5, what you get is in the container image, sorry, in the, well, let's say what you get in your container is the latest version of the 6.5 branch, and next thing will be 7. So you can probably already look at the Helm charts and see what they're going to do with 7, but don't take it too literal because the products for 7 are far from being released at the moment. After you've done that, well, you do what you do in a Kubernetes environment. You just delete everything again. Instead of stopping a process, right, you just delete everything. And this is actually what you do with the remove all script here. It just actually checks what you have installed in your namespace, and then it deletes all the Helm charts or the Helm releases which you have created before. If you use it with the -n option, it will even delete the namespace. And then if you execute a kube get pods, kube control get pods, of course, you shouldn't find anything anymore because it is all deleted. Just checking the time. We have a little bit more time, which allows me to go to another slide here. And that gives us a bit more information about what you need on your cloud provider. If you run it, and this is actually taken from the Google Cloud environment. Of course, there is the Kubernetes engine, but honestly, when I started playing with the Kubernetes engine in the Google Cloud, I thought, this is it. This is what we need. This is what we want, but it's not. You need much more, right? So for instance, you need network services. You need identity and access management because you have to create a couple of technical users to do some jobs. You need storage, which is in this case for backup and is not part of the storage you would have in your Kubernetes environment. Well, compute engine, this would allow you to look at your nodes. Well, they are actually running in the Google Cloud, but the content on these nodes is actually maintained or is deployed through Kubernetes. You can run it with one pod or with a couple of node pools, depending on how big you want to scale the whole thing. So just to give you a little bit of an overview of what you might want to do there. Now we have a few steps here which the instructor would need to do to prepare the environment for the students. I couldn't resist actually copying that in, but I'm not going through all the steps here in this environment now. So let's just fast forward a little bit and talk a little bit about secrets for accessing a private Docker registry. I mentioned before, the Docker images which are provided by ForgeRock are not supported. The Docker files to create those images are supported, and of course the access manager, which is in that Docker image, is fully supported, but not Tomcat and not the Java engine, for instance. So you have to create your own private Docker images, and you would probably have them in your own private Docker registry. And that changes, of course, a little bit on how you can deploy the cluster automatically. Our Helm charts, as we provide them from the Git repository, assume that you just download from our public Docker registry, which has moved to Google now as well. So this is where the files, but the Docker registry is public, so you can access it without any authentication. If you do it with your own private Docker registry, obviously you don't want them to be publicly available, so our Kubernetes environment needs to authenticate against your Docker registry, and you have to play a little bit with keys. So you have to provide your Docker environment a key, then which it is using to download the Docker images from your own Docker registry. Same actually with the configuration repository. Now, the configuration repository we are using with the CMP platform, for instance, that is a public repository, so all the configuration is available without authenticating. But if you want to have your own configuration, and sooner or later, of course, you also want to play with your own configuration, then that will be on a private GitHub, for instance, and then again, you need to provide your Kubernetes environment with your own key so that it can access the configuration. Let's go forward a little bit here and talk a bit about more objects, which are also needed. So what you deploy, this is a slide you have seen before already, right? Only what is in the students, each student's namespace has changed a little bit. We're looking at different aspects here. Before we looked at all the pods which will be deployed, but there is also services and secrets. Remember, I just talked about those secrets which you have to deploy so that they are available for your Kubernetes environment to download the Docker images, for instance, or to download the configuration. There is also config maps, which you have to tune in the right way so that they make available, for instance, what is the address of your own Docker registry, or what is the address of your repository where you have the configuration. And a few other objects are going to be created in the namespace here. The next slide should give us a little bit of an overview of how things work, let's say. So in the middle, well, that still actually represents the big internet. And then we have the Docker registry where you get your Docker files. Then there is the ForgeOps GitHub repository. Remember, this is the one where we have the Helm charts, and the Helm charts will be downloaded into the computer from which you run your Helm commands, for instance, or your kube control commands and so on. So your client-side commands, because the Helm charts need to be available for the Helm command, of course. It's a bit different with the configuration. The configuration needs to be, and if I talk about configuration, I mean the configuration of your access manager, for instance, which realms you have configured in your access manager and which OAuth2 clients you have configured in your access manager and so on. So this kind of configuration you will have, well, you can get it from ForgeRock in the ForgeOps init repository. Excuse me. But this is not what you want to use on the long run. You would, of course, like to use your own configuration. So what we do in the class, for instance, we just actually fork and copy that locally. Actually, locally in this case means you copy, you get your own version, you clone it actually. You clone that repository to have your own version, and then you can start changing it. But keep in mind, it's still the Kubernetes environment which needs to have access to the configuration. So it needs to be available for the Kubernetes environment. So it has to be on GitHub or any other Git repository, which is then available for the Kubernetes environment, so it can download this configuration. I'll show you in a minute a little bit in how that exactly works. Well, a little bit how it exactly works. There is an extra Helm chart, which is actually called FRconfig. FRconfig prepares your environment for your needs. So if you don't use our public Docker registry, the Helm charts need to be available to access your private one. If you want to use your own configuration repository with the branches of your own choice, then the machinery here needs to know where it can be accessed. So what we decided in our environment here is we first run an FRconfig Helm chart. The main purpose of that FRconfig Helm chart is to set some kind of environment variables in your Kubernetes environment, which is available for all the pods in that namespace then, so that they can find where is the Docker repository or where is the Git repository where you can download that configuration. So what it actually creates is some secrets. So you get the access keys to access the Git repository, and it creates a config map to set these. I like to call them environment variables because that's what my students often understand easily if they are not that familiar with Docker. If you're familiar with, Kubernetes precisely, of course, then you know what the config map is. After you run that config map, before you run the config map, you also want to tune it a little bit with your own values file, right? So, well, we call it test FRconfig here. What you set in the test FRconfig is especially what is the address of the configuration Git repository where it can download the configuration which you want to use for your access manager and your identity manager and so on, and which branch should be used here. After you run that frconfig Helm chart, you can see what it has done for you. So you will find that it is deployed. And then if you do a kube control get secret frconfig, it tells you actually all the secrets which are in that namespace. And well, there is one, no, sorry, the secret which is called frconfig. And of course, it doesn't show you the value. That's why it is a secret. Well, it would be stupid to show the value, which is a little bit different for the config map. For instance, for the config map, you could actually, if you do a describe, you would probably also see the config map and the values we are setting in that config map. Let's see. No, it's getting too late. Otherwise, I would like to go into my own Google environment and show you, for instance, the config map. But it's getting too late now. Let's have three last slides where I like to start with the last one, actually. And that shows us what happened or what you have in your Kubernetes environment in your Google cluster after you deployed the OpenIG pod. Requirement is always that you first deploy the frconfig Helm chart to make these environment variables available. And then you would run, for instance, the OpenIG pod. The OpenIG pod itself actually is comprised of two containers. There is the container which is the identity gateway itself, and then there's another one called git init, which is a temporary container. It will actually start, download the configuration from the Git repository, and put it into a volume which is shared between those two containers here. So it makes it available for IG, for OpenIG, or ForgeRock Identity Gateway. And then it goes away. That the whole task of that container is only to once download the configuration and make it available for IG, and IG actually picks it up directly from the place where this container has put it. If you want to apply a change, well, you make a change in your configuration repository here after you have developed it in your development environment, tested and everything. You apply the change here, you wipe out the pod. You're actually just deleting the pod, which means Kubernetes is not happy because there's a discrepancy between what should be there and what there is. So Kubernetes will create a new pod. It will actually fire up the git init container again. The git init container will actually download the new configuration, the new version of the configuration, and make it available for your new OpenIG. That is the most simple of our three deployments here. A little bit more complicated is OpenIDM, because OpenIDM also needs a repository. So we need to also deploy that Postgre pod here, which is shown very grayish here because it's not too much ForgeRock. I guess that's the reason why it is a little bit grayish and not so prominent. We have an OpenIDM container. We have a git init container here again. The git init container does the same thing as before on the identity gateway. It connects to your Git repository, downloads the configuration, and then OpenIDM, or the ForgeRock Identity Management Container, has access to the configuration, and it starts actually from these configurations. And then that Git container is not needed anymore. But there's another one, and that is a little bit interesting to explain maybe. So the task of that Git container here is, let's assume this is a development environment. So this is the environment where you change configurations. And since it's a development environment, you're totally happy to apply the changes through the REST interface of OpenIDM or ForgeRock Identity Management. You download your admin GUI into the browser, make your changes, commit them to the identity manager, and the identity manager puts it on the hard disk. And then that Git container could be used. There's a script available in there which you can just execute from outside, and that what the script does, it just actually uploads the new configuration into your Git repository. Let's mentally switch now to your production environment. In your production environment, you now need to get the new configuration into your OpenIDM pod, and you do that, of course, again by deleting the pod. It will be recreated. The git init container will do its job, downloading the new configuration, which you have got through your development in the development environment, and then it will actually fire up the identity manager with the new configuration. Down here, we also have a directory server that would be an external directory server as a user store. We just run it in our environment here in the training, for instance. We have OpenIDM configured to talk to an external directory server for deploying users into it. And that could be, of course, be the user store of an access manager, which makes use of those users then. And finally, the most complex part is AM here, 3 directory servers. Again, there's a Git init container downloading the configuration from your Git repository. And we have a Amster pod here as well, well, the code pod is called an Amster pod here, and there's an Amster container. In the current version of AM, you need to push in the configuration which are available in files from the Git repository. You need to have a mechanism to push it into the REST or through the REST interface into the Access Manager so it can store it in its configuration directory server. And that is the purpose of that Amster container here. Later, that Amster container does not go away because you may want to reuse that Amster container to export the configuration. Again, if this is the development environment, and only if it is a development environment, then you may also want to change the configurations very comfortable, very easy through the admin UI, and then you need somebody that extracts it again from the configuration through OpenIM, of course, from the configuration directory server, puts it on the hard disk on the Amster pod here, and then again here is the Git container, which actually dumps or uploads the new version of the configuration in your into your Git repository. Yeah, with that, I'd like to conclude. Well, there's another Git container, a Git init container. What that does actually, it gets another configuration part, another part of the configuration, which is then used in a script which can be executed after the Access Manager here is deployed, and you can execute whatever you need to execute after the Access Manager is deployed. Of course, we could discuss now, is that the right way to do it in a Git container, right? To have a Amster pod which actually needs to execute something to get the configuration in your configuration directory. This will actually change anyway, because in the next version of the Access Manager, you don't need the configuration directory server anymore. You can only use, or you can use only files, same architecture as with the Identity Manager or with the Identity Gateway. And then you don't need that Amster command anymore that reads the files and pushes them into the Access Manager. That can be done automatically because the Access Manager directly reads it from the file system, which will simplify the whole thing a lot. With that, I'd like to conclude my part here. I hope you enjoyed it a little bit. I hope you learned a little bit. And of course, I would especially hope to see you in one of the next classes about the ForgeRock DevOps environment.
Thank you very much for the presentation. There are a few questions in the Q&A box. Matthias, if you cannot see that box, I can read out the question to you.
Yeah, well, I tried to get it. It's just this, well, it's just on, I do see the Q&A box and I should, yeah, I see it. Okay. So I see, maybe it's easier if I read it myself.
Sure, yeah.
Is that fine? Yeah. There are even 2 answers already. Okay. Michael Heller, while the presentation is on Docker Kubernetes, can the comment an Ansible deployment at the end of there, if there's time? Yes and no. We currently don't have an Ansible strategy in ForgeRock because we focus on Docker and Kubernetes installations at the moment. Some of the concepts may even apply for Ansible, but I'm afraid you would have to do the scripts and everything your own. I wouldn't know that we from ForgeRock provide any Ansible. We did look into that some 5 or 6 years ago. Then the Docker containers became so violent and so tempting that we changed the strategy and go totally Docker now. What are the limitations of running a directory server as a container? Would you consider running a config store outside Kubernetes? Yes, you got the point completely right. There are limitations, and the question is a directory server the right, or is a container deployment the right thing you want to do with a directory server? You can do it. What we don't show on the slide here is, or do we show it? The directory servers here have their database files, and the database files would be stored in persistent volumes. So they don't go away when you restart the pod here. But then, of course, we also kind of losing a little bit the charm of deploying everything with containers if you then persist the most important part anyway. We have limitations at the moment with the directory server. The directory server has a, I believe, very smart replication mechanism. But when it was designed 15 years ago, we didn't have the cloud, we didn't have Docker containers in mind. And unfortunately, it has its limitations. So you cannot easily scale up and down with the auto scalability of your clusters and of your ingress controllers and so on in a Kubernetes environment. For the access manager, it's simple to just add 5, 6 more pods to your existing installation. With a directory server, well, you could add more pods with more directory servers, but the replication wouldn't dynamically grow. So in other words, they wouldn't replicate with each other. So we have the limitation in the moment with the directory server that you need to set up the replication or decide on how many replicas you want to have in the moment when you do your first deployment. Or you would actually have to do everything again if you want to change the number of replicas. So this is a bit of a pain point in the moment, but we're working on it. In 7, that will be different so that the directory server can also scale. But I said it's a bit of a pain point, which is maybe not the right way to express it, because we hardly, I wouldn't say we hardly, but the directory server is not that easy to become the bottleneck, let's put it that way, because they just scale vertically like hell. And as mentioned before, we have actually 100 million entries on one directory, and that, well, we run it with 2 instances then, but that works already, right? So it's a question whether this is really your problem. It can be a problem. I have to accept that. And as I said, we're working on improving the situation here. That was the 2 questions in the Q&A.
In the chat, there were a few comments, or rather requests to, if you have any suggestions or links for tutorials or more of a brief introduction to Docker or Kubernetes.
Yes, I do. There is on Plural site, if you have an abonnement on Plural site, there's a very good presentation from a guy called Nigel. And he's a real Docker fan, and he does Docker up and down and left and right and all the day in and out. And he's done some very nice presentations in introducing you into Docker. And there's also Kubernetes there. The guy also wrote a book about Docker and about Kubernetes, which you can get where you get your books. So that is a nice tutorial, for instance. And we are also looking into a another class, which is actually a 1-day class, which we may want to, which you can also, well, this is not a class where you have to physically go. It's actually, you can do it on your own pace, self-paced class. And I actually have to admit, this is my task to look at it and see whether this really brings the people to where we expect them to be when they come to our class. I have a bit of a suspicion that 1-day introduction into Docker might not be enough. On the other hand, during the class, of course, we also it's really necessary that you have to understand, that you have understood what Docker containers are. We always have a few minutes here and a few minutes there to also introduce you that and to bring you up to speed a little bit. But you know how it is. As I said, we don't send anybody home, but if you really have only very little information already about Docker and Kubernetes, and in addition, then we talk about all what we do in ForgeRock with that technology, it might be just a little bit much to grasp and much to take in on during those 3 days. And we could maybe also, well, if you sign up for the class, then we will also send you more links to how you can get prepared for that. So on the Docker and the Kubernetes side.
That's great. Thank you so much, Matthias. We are officially at the end of the presentation, and thank you all for attending. Please note that the recording of the presentation will be sent to all registrants by the end of the week. And as a reminder, our June 11th class is guaranteed to run, and there is a promo. Right now, information's posted in the chat. If you're not able to make our June 11th class, don't worry, we have other classes scheduled, the next one being July 10th, and more dates and details can be found on our website. Thank you again for joining us. I hope you all enjoyed the presentation.